In this video, we're going to learn what it means to solve an equation. But let's first talk about how to recognize an equation. So the most important attribute of an equation is an equal sign. So equation must have an equal sign. So if you look at what's written here, you can see the equal sign, right? So that means that we're looking at the equation. Now, what does it mean to solve an equation? Well, to solve an equation is to find its solution. But what is the solution? Solution is a number that makes an equation true when it replaces the variable in the equation. So as you can notice, this equation has a variable, right? So that is variable. So if we can find a number such that when we replace this variable with that number, we get a true statement. What does it mean, true statement? Well, the left-hand side equals the right-hand side. That would be the true statement. Let's try the following. Let me ask this question. Is x equals 5 a solution to this equation? So to check, what we need to do, we need to take 5 and replace x with it and see if we're going to get true statement. So I'll say to check, substitute 5 for x. If I have more than one place where I have x in this equation, then I would replace every x with the 5, but we only have 1. So it means that that's how it's going to look like. 2. Now 2x means that it's 2 times x, right? So when I replace x with 5, it's going to be 2 times 5 plus 3. And the question is that equal 17? Is the left-hand side equal to the right-hand side? Well, to find this out, I need to simplify the left-hand side. 2 times 5 is 10. So it's 10 plus 3. Is that equals 17? And 10 plus 3 is 13, right? Well, that's not true, right? 13 is not equal to 17, so that's false. This is not true, which means that x equals 5 is not a solution to this equation. No. Okay, but how about if we try 7? Is x equals 7 a solution? So we have to repeat the process, right? So this time I have to replace x with 7 and see what happens. So 2 times 7 plus 3, is that 17? Does that equal to 17? Now 2 times 7 is 14 plus 3, does that equal to 17? 17 on the left-hand side and 17 on the right-hand side. So yeah, that's true. So that means that yes, x equals 7 is a solution to this equation. So now we can see how we can check whether a given number is a solution or not. But how do we find this number? If we're given an equation, it's impossible to check all the numbers, right? There are infinitely many options. So how do we find a number that's a solution? Well, let's talk about that. We're going to try an example. So we're going to try to solve this equation. In other words, we're going to try to find its solution. And we want to find something that looks like this. X equals a number. So in other words, we want to have x by itself on one side and just some kind of number that's happened to be solution on the other side, right? So when we look at this equation, that's going to be our goal. I'm going to write it down. So goal to isolate x. So get it by itself. Get it by itself. Let's think about what we have here. So here's that x, right, that we want to isolate. So that x wants to be alone. It means that, and right now we have some numbers next to it, right? We have 5 that's right next to it. We call it coefficient, remember? And we have this -4 or -4 next to it. So our goal will be to get rid of those two numbers. And there is an order, the best order in which you want to get rid of those numbers, remove those numbers, is the following. So number that's right next to x, that we call coefficient, leave it for the very, very end. No matter how long your equation is, leave that number for the very last step. Start with all other numbers. So it means that we're going to start with -4 right here. And think this way. I don't want to have -4 on this side. I want it to disappear. And think about what operation you can apply so that -4 disappears. And in math, to disappear, it means to become 0, right? So what will make 4 to disappear? Well, if we add 4, if we do -4 plus 4, then it becomes 0, right? And it means that it disappears. But when we solve equations, we have to remember the following principle. We have to keep this equation balanced. So imagine how you have sides of the scale. So that's one side of the scale and it's the other side of the scale. And it's balanced to start with. And when you do steps, when you're solving an equation, you want to keep that scale balanced. And when we add 4, we kind of like put 4, let's say 4 pounds on this side of the scale. Well, to keep it balanced, we have to put same amount on the other side. So when I say I need to add 4 over here to cancel -4, I have to add 4 on the other side as well. Now, on the left-hand side, -4 plus 4, that's 0. So it means that it disappears, and I'm going to write down what I have now. Now the left-hand side is just 5x, -4 is gone, and then the right-hand side is 31 plus 4, so it's 35. Right? So that's what we have now. So we're getting there. See how we have one less number. Now we have to think how to get rid of 5. And so the good way to think about getting rid of numbers in general is in terms of the opposite operations. So here we had -4, 4 was subtracted, and then we added 4, right? So that's how it disappeared. Now if you have, what kind of operation do you have here, by the way? 5 glued to x. Remember, it means that it's multiplication here, so it's in reality it's 5 times x. So to get rid of this 5, we can divide, we can do reverse operation, we can divide by 5. And I'm going to write down division using a fraction bar. If you haven't refreshed, we haven't refreshed fraction yet, but that's all we need for now. So that's division. So divide by. Now, technically, what happens when I divide 5 by 5? It's not like everything disappears. 5 divided by itself equals 1, right? So in reality, I'm getting here 1x. But remember, coefficient 1 we don't have to write because 1 times x, it's still x. So I can simply, in this case, I can simply cross out 5s and say that, well, it's just x that's left on the left hand side. But I forgot to do something, right? Remember how we talked about keeping that scale balanced? So by dividing the left hand side by 5, I made my scale out of balance. I put it out of balance. So to keep everything balanced, I have to do exactly the same operation on the other side, on the right hand side. If I divide on the left, I have to divide on the right. And if I divide the right hand side by 5, it's going to be 35 divided by 5. So that's 7. We got 7 again. You know what? It just happened by accident. Trust me, not every equation will have that solution. It's just happened. It's 7 again. But yeah, notice how we end up with this, with what we wanted to end up with. So our goal was to get x by itself, to isolate x. Well, here it is. And that number that's on the other side, x equals 7, that number, well, that's going to be a solution. Let's check. So that's solution. It's always a good idea to check. How do we check? This is going to be a solution if this number makes equation true when we replace x with this number. So let's try it. 5 times 7 minus 4, is that 31? Let's see, 5 times 7 is 35 minus 4, is that 31? Yeah, I think so, right? 35 minus 4 is 31. So I get 31 equals 31. Yes, and technically, only after I checked, I should have boxed it. So checking is a good idea if you have time for that. So that's how you solve linear equation. So I just realized that even though I mentioned word linear before, it was in the title of the topic, but I didn't say what it meant. What it meant to be linear equation. So we call equation linear if all variables in that equation are raised to power 1. So as you can notice, this x, well, we don't see a power, right? We don't see exponent, but that's because it's raised to power 1. So I'll make this note. Linear means each variable is raised to power 1. So each variable is raised to power 1. And then if you're dealing with a linear equation, then what we just talked about, as far as solving it, getting x by itself, that's going to be usually our approach.